lecture series of operating system. In today's session, we are continue with the topic process synchronization. Myself Kunal Panchal, your instructor. In this particular session, we are going to discuss Peterson solution, which is nothing but one classical solution of process synchronization when we have two set of processes. Means Peterson solution can be useful when we have two independent processes, not more than that. And with the help of this solution, we can solve the problem of critical section. So, as we have discussed earlier, in the case of process synchronization, specifically in critical section problem, if you want to write any solution, that solution needs to satisfy three main criteria, which is nothing but mutual exclusion, second one is progress, third one is bounded weight. These three criteria needs to be achieved. But out of these three criteria, only two criteria are mandatory. Means we need to have one solution through which at least we need to satisfy mutual exclusion and progress, because bounded weight is optional criteria. If you achieve that stuff, it's well and good. If you are not able to achieve it, it's not an issue. Okay, but mutual exclusion and the progress needs to be achieved anyhow. Then and then that solution would be considered as valid solution in process synchronization. Fine. So today we are going to discuss one solution which is known as Peterson solution, in which we are going to see how we can achieve these three criteria with the help of these in process synchronization. So let us discuss Peterson solution in detail. So we will take one scenario in which we will try to see and try to understand whether we can achieve these expected criteria of process synchronization as far as critical section problem is concerned or not. Okay, so let us discuss these things with the help of this particular scenario in which we have two independent processes. One is P1 process and second one is P0 process. Means these two are independent in nature, they are not dependent with each other. Okay, these two processes we have, and these two processes wants to perform a particular task. Like say for example, in P0 process, it contains set of code. Same way in the case of P1 process, it contains set of code. So by having this set of code as far as P0 or P0 and P1 is concerned, okay, let us discuss. So this is we can say a Peterson solution code of two different processes. But how we can say that this solution is valid solution to avoid the problem of critical section when it achieves three expected criteria. Then we can say that yes, it is valid solution. So let us consider this P0 and P1 process. Okay, and by having these two processes, let us discuss with this particular code, is it satisfy the expected criteria of process synchronization or not. So in this particular table we have code of P0 and P1. Then we have used one variable called turn. Turn variable we have used in this particular code, and turn is nothing but one boolean variable, and at a particular moment of time the value of turn can be 0 or 1. Means what? Turn is one type of boolean variable that things you need to keep in your mind. Okay. One more thing we have used in this case, is nothing but one Boolean array. So flag is one type of Boolean array, and its initial value, and it is defined for these two different process P0 and P1, and initial value of this flag is what? False, because it is Boolean array. So definitely the expected value would be true or false. So by default, initially we have set this value of these two process with respect to flag is set to false. Okay, so we have used one Boolean variable and one Boolean array, okay, to satisfy the criteria which is expected for critical section problem. So let us, by having this set of code and these two type of we can say variable, let us discuss, can we achieve the first criteria, which is nothing but mutual exclusion. Okay, so let us discuss these things. So by considering the same set of code, in this particular figure we are going to check mutual exclusion. You know the property of mutual exclusion very well because we have already discussed in previous sessions. Okay, mutual exclusion means what? At a particular moment of time, only one process can enter into critical section, and when process requires to enter into critical section, when it requires shared resources for its execution. That we already understood. Yes. Okay. Now, if you want to achieve mutual exclusion, so by having this set of code at a particular moment of time, either P0 or we can say P1 process can enter into critical section. Okay, at the particular moment of time, more than one process should not be entered into critical section. Okay, so let us discuss this code, and by having this code, can we achieve mutual exclusion property? So initially, as I told you, the flag array value was set by false. Okay, in terms of process 0 and process 1. Okay, so now let us start the execution of P0 first, in which we have mentioned one while loop. So while 1 means what? While true means this loop can be executed for n number of times. Okay, so there is no limitation. Whenever you want to execute this, you can execute it. Okay, and the first statement in while loop is flag of 0 is equal to true. You can see flag of 0 is equal to true. T stands for true. Okay, so initial value of flag of 0 was set by false. So now we have set to true. So true we have mentioned in the flag value. Then turn variable is equal to 1. Means as I told you at a time, turn variable value can be 0 or 1. So in this case we have set turn is equal to 1. Okay. Now we have one condition. In this case, in inner while loop, while turn is equal to 1 means right now we have set the value of turn variable is 1. So this condition is satisfied. Yes. So this condition holds true. Yes. Then and okay, logical and we have used. So and condition we have. So means what? If this condition is satisfied and the second condition is satisfied, then and then this condition holds true. Yes. Okay. So second condition is what? Flag of 1 is equal to true. Yes. So it means flag of 1 is equal to true means you can see at the bottom flag of 1 value is false. Yes. And we have checked condition flag of 1 is equal to true in that case. So condition is not satisfied in this case. So the second condition is false and the first condition is true. So true and false is equal to false means definitely the condition whole condition is false. So if condition is false, you need to come out from the loop. Yes, but you can see in this particular loop we have checked the condition, but these loop do not have any statement because it is end with semicolon. So this is we cannot say it is a loop. It is one type of trap, we can say trap. Okay, so once the condition hold true, it means what, we will busy in the loop only. But when this condition holds false, in that case we will come out from this loop. Okay, and the P0 will enter into a critical section. Means it will start using the shared resource. So you can see I have denoted it in yellow color P0. Right now it is in critical section, means what, it is using shared resources. Okay, so in this particular moment of time, while P0 using shared resources, means what, it is in critical section. At this particular time, suppose if context switching is happen, means now P1 is forcefully preempted the execution of P0, means context switching is happen. So what will happen? P0 is already using critical section, so no other process is allowed to enter into critical section because we are talking about mutual exclusion property. So that property needs to be achieved. Yes. So let us discuss. Once it is context switched, so in that case, execution of P1 would be start. So flag of 1 is equal to true. Means flag of 1 is equal to true. That condition will to set. So that we need to discuss in this particular slide. So flag of 1 is equal to true. So flag of 1 we have set as true. You can see in the flag variable. Okay, and turn variable value we have set to 0. So turn is 0. Okay. Now we need to check the condition. While turn is equal to 0, condition is true. Logical and flag of 0 is equal to true. Flag of 0 is equal to true. Yes, because we have earlier we have set flag of 0 is equal to true. Yes, so means both the conditions are true. It means we will not able to come out from this loop. So what P1 will do? P1 will do the busy wait. Yes, it will wait until any of these condition holds false. Then and then that P1 process can come out from the loop. So it means what? Can we achieve mutual exclusion? In this case, yes, we can say that we can achieve mutual exclusion. Why? Because when P0 is using critical section, or we can say it is in critical section, P1, even though it is interested, that process cannot able to enter into a critical section. Yes. So one more cycle we can check for mutual exclusion in the next figure. So suppose, for example, in this case, suppose in the previous case we have discussed P0, say for example, come out from the critical section. So definitely the flag of 0 value would be false. Yes, and flag of 0 value is false. In that case, what? And then context switching will happen. Okay, so P1 will start check its condition once again. So turn variable value is 0. Yes, condition is true. And flag of 0 is equal to true. Means what? Flag of 0 is equal to, in this case, the value would be false. F, because now P0 is come out from the critical section. Yes. So if it is flag of 0 is false, so definitely the one condition is true and second one is false. So definitely true and false is nothing but false. Yes. So now P1 can able to enter into critical section. Yes or no? Because true and false is nothing but false. Means what? When condition hold false, it means we need to come out from the loop. So now P1 is using critical section. Okay. So in this way we can say that yes, mutual exclusion property is achieved. Okay. But this is not sufficient to consider the Peterson solution is a valid solution. Why? Because one more property we need to achieve, which is nothing but progress. Okay, so let us discuss how we can achieve progress by having this Peterson solution. Okay, so first of all we need to check, in the progress we need to check first, if any process wants to enter into critical section multiple times means what? In that case system needs to allow that process into enter into critical section multiple times, because it is one of the property of progress, we can say. Okay, so progress means what? If any particular process wants to enter, means what? Progress property we have already understood in the previous session. Means what? Those processes are interested to enter into critical section. Only those processes we need to allow to enter into critical section. Those which are not interested in that process, we don't want to enter into critical section, don't want to allow into critical section. That is the progress property. Yes. So let us discuss that stuff. So let us again, we are talking about this same set of code of P0 and P1. Let us execute P0 code first, and flag of 0 is equal to 2. So I have set the flag of 0 is equal to true and turn variable value is 1. Now we need to check the condition turn is equal to 1. Yes, true. It is, first condition is true, and flag of 1 is initially, you know very well, it is set to F, means false. So in this case it is true, means what? Condition is not matched. So true and false means what? False. So now P0 can able to enter into a critical section. Why? Because the condition is false. So we need to come out from the loop. So P0 enters into critical section. Okay. Now what we need to check in this case? Once P0 uses critical section and come out from this critical section, and again P0 wants to enter into critical section second time, is it possible? So let us check it. So once the P0 is using the critical section and it will come out from the loop, so definitely flag of 0 would be false. So I have set the flag of 0 is equal to false. Now again P0 wants to enter into critical section, so we need to check flag of 0 is equal to true. So flag of 0 is equal to, we need to set true. Okay, then turn variable is nothing but value is 1. Yes or no? Okay, so then while turn is equal to 1, condition is true. Yes, and flag of 1 is nothing but, flag of 1 value is nothing but true in this case, but we have flag of 1 is equal to false. Means what? These two conditions are, these two values are not matched, means condition is false. So one is true and second one is false. So definitely the outcome is false. So we need to come out from the loop. So P0 can again enter into a critical section if it wants to enter into a critical section once again. So in this case, we can say that yes, progress is achieved. But one more condition we need to check: is there any deadlock situation occurred in this particular case or not? So once there is no deadlock, in that case we will see this solution is valid solution. So let us check whether deadlock is present in this case or not. So in this case again we have set the value of initial value of term is, we can say any value, it can be 0 or 1, and the flag value is, say for example, flag of 0 and flag of 1 is initially set by F, false, yes, default value. Now we have started P1 first instead of P0. So flag of 1 is equal to true, flag of 1 we have set true, turn variable is equal to 0 we have set. Now at this particular moment of time, without checking the condition, I am doing the context switching. At this particular place you can see the context switching is happening over here. Once we set the value of flag of 1 and turn variable, now I am doing context switching. Now P0 will start its execution. So means what P0 is also interested to enter into critical section. Okay. So in that case, what will happen? So once the context switching is performed, then P0 will start its execution and flag 0 value would be set to true and turn variable would be 1. Okay. Now condition we to check while turn is equal to 1. Turn value is not 1. Yes, condition is true. And flag of 1. Flag of 1 is equal to true. Yes. So in this case condition is true. So it means what? True and true. Both are true means what? P0 will not come out from this loop. It will do the buzzy wait. Yes. Okay. But at this particular moment of time, P0 cannot able to enter into critical section. Means what? In this case, P0 and P1 both are interested to enter into critical section. Yes. That's why they have requested. But P0 cannot able to enter into critical section right now. Now, after some time, the context switch back to the P1 and remaining instruction will be executed of P1. So, the while condition again we need to check. Can P1 able to enter into critical section? Yes. So, we need to check turn is equal to 0. Okay. So, turn variable is condition is what? Because we have said the turn variable is equal to 1. So right now this condition is false. Okay. And flag of 0 is equal to true. Means what? That condition is true. So flag of 0 is true. That condition is true and turn variable condition is false. Yes. So now means one is true and one is false. So definitely the outcome would be false. So we can come out from this loop and P1 can able to enter into critical section. Yes. So it means what? If both the processes are interested to access the said resource at same moment of time, but only one process can enter into critical section and there is no infinite wait as far as these two processes is concerned. Because at least one process can able to enter into a critical section. So definitely in this case also there is no deadlock. Means what? Now we can say that the second property, progress, is achieved successfully. So these two mandatory criteria we have achieved. It means that this Peterson solution, okay, for critical section problem is valid. Okay, for process synchronization. But the third condition also need to check if it's hold true, it's fine. But if it holds false, in that case it doesn't matter because we can consider this solution as valid because the third bounded wait scenario is optional. So let us check whether we can achieve bounded wait or not. So bounded wait means what? After fixed period of time or after some time, if process is requested, that process needs to able to enter into critical section. Okay, that is the word bounded wait. So let us check. Suppose the turn variable value, okay, is suppose if you are executing P0 in this case and flag of 0 is equal to true, yes, the turn variable we have set 1, condition first turn is equal to 1 is true and second flag of 1 is nothing but false. Flag of 1 means what? False, and the condition is flag of 1 is nothing but true. It means what? These two values are not matched. One is true and one is false. So it means the output would be false because one is true and one is false. So we need to come out from this loop. So definitely P0 enter into critical section. Okay. Now, and when P0 come out from the critical section, but at this particular moment of time, if context switching is happen, so what will happen in this case? So once P1 started its execution, so flag of 1 would be set to true because context switching is performed and P0 is right now in critical section. Yes. So flag of 1 is equal to true and turn variable is set to 0. Now turn variable value condition is true and flag of 0 is nothing but true. Means what? Both are true. In this case, P1 will wait a buzzy wait because both the conditions are true. And after a fixed period of time, definitely P1 can enter into critical section. How? Let us check. Once P0 come out from the critical section, so definitely flag of zero value would be set as false. Yes or no? Yes. Okay. And then again it will switch back to a P1 process because P1 is waiting to enter into critical section. So in this case, term variable is zero, condition is true, but flag of zero is true in the condition, but actual value of flag 0 in this case is false. Yes or no? So definitely one is true and second one is false. So total outcome is nothing but false. So we need to come out from the loop. So P1 can able to enter into critical section after some time. So it means what? Surprisingly, we can achieve bounded wait as well. Even though it is not mandatory, still we can achieve bounded wait in this particular scenario. Okay, so with the help of Peterson solution, we can achieve all the criteria of critical section problem in process synchronization. Okay, but there is one limitation. This solution is limited for two processes only. When we have more than two processes or let's say n number of processes, in that case, this solution will be failed. So for that we need to use for n number of processes, and if you want to have valid solution, in that case we need to go for semaphore. Okay, that we will see in the upcoming session, but you have to keep these things in your mind. Peterson solution is a valid solution, but it is valid for two processes only. Okay, so I hope it was clear to you. Thanks for watching this video. See you in the next one.